Hey guys, welcome back to Civil Learning Online, and today in this video I am going to discuss about simplex method. In the previous video I have discussed about how to solve a problem which was about maximization of the inequality based upon the objective function, and this time this problem is related to minimization. So I hope you are going to enjoy this video. Without delay, let's get started. Let's begin the solution of this problem. Here we are asked to minimize z equals to 3x1 plus x2 subjected to 2x1 plus x2 greater than or equal to 14, x1 minus x2 greater than or equal to 4, x1 x2 is greater than or equal to 0. So guys, solution of the any problem based upon the simplex method, and in which we are asked to minimize, a bit different from what we used to do in the problem in which we are asked to minimize a given equation. So here the first step is going to take the create augmented matrix of the given inequalities, and we will just find the transform of that matrix, and then we will solve further as we used to do in the maximization problem. So here I am going to write solution, and let A equals to augmented matrix. So our augmented matrix is going to be 2 1 1 minus 1, and draw a line like that, and the other elements are 14 4, and now the element of the principal function, that is 3 and 2, 3 and 1, sorry, here the coefficient is 1, so 1. So we have A equals to this augmented matrix. Now find the transpose of this matrix. So what we will have, A transpose is going to be, we will simply convert the row into column. So we will have here, draw a line like that, and we have this row, so 2 1 14. Similarly we have 1 minus 1 4, so 1 minus 1 and 4. Here we have 0, so we will have here 3 1 0. This is matrix. So after finding the transpose, what we will need to do is, here the question was about maximize, we have to convert this here the question is to minimize, so we have to convert this minimize to maximize. For that we have to perform a dual problem of the given linear programming problem. So I am going to write here now the corresponding dual problem of given LP problem is. So here the corresponding dual problem is going to be, we have to rewrite the question according to this the matrix we have got after transposing. So we will write here maximize, and here in the question it was z, so we can take any variable. Let me take it w, maximize w, you can take any variable, so but it should be capital, so capital W equals to 14, and we have x1, so in place of x1 we will write y1. So again you can take any variable, but remember the variable must not coincide with another variable. So here I am just taking, in the question we have x1, so I am going to rewrite it as y1, replace it by y1 plus 4, and in place of x2 I am taking y2. Similarly we have to convert these inequalities also according to the y1 and y2 form. So again we will replace x1 with y1, but this time we will write it according to this transposed matrix. So 2 in place of x1 we will write y1 plus y2 is less than or equal to 3. Here it is greater than, so here this time we will take less than or equal to 3. Similarly again we will have y1 minus y2 is less than or equal to 1, and we will have here x1 x2 is greater than or equal to 0, so we will have here y1 y2 is greater than or equal to 0. Now we have to do the process as we used to do in the maximization problem. So what we need to do is we have to introduce some non-negative slack variables. So I am going to write here, it was our step 1. In step 1 we have formed the corresponding dual problem of the given linear programming problem, because the question was based upon minimization, so we have written it maximize W. Now we will have step 2, and in step 2 what we will do, introducing non-negative slack variables. And this time I am going to take slack variable as x1 and x2. It is because at the end we will require the value of x1 and x2, which is our original variables in the given equation. So after forming the augmented matrix and transposing and forming the dual problem, we have to take the variable x1 x2 which is originally present in the given equation as our slack variable. So we have taken x1 and x2 as a slack variable, and x1 and x2 are also greater than or equal to 0, so you may write it non-negative or simply introducing slack variable, that is up to you. And now proceed further. So if once we have mentioned that we are going to introduce a slack variable, we will write here, we have, what we will have here, we will have here 2y1 plus y2 plus 1 times x1 plus 0 times x2 plus this w, 0 times w equals to 3. Similarly we will again have y1 minus y2 plus 0 times x1 plus 1 times x2 plus 0 times w equals to 1. And again the concept which I told you, that for maximizing this is our objective function, and while writing the objective function, what we need to do is we have to write the elements of our right hand side to the left hand side. So on writing this 14y1 to this side, it will get minus 14y1, so we will have here minus 14y1. Similarly this will get that side, so minus 4y2 plus 0x1 plus 0x2 plus 1 times w equals to 0. Now we will form the first tableau, and that is going to be our step 3 of this numerical problem. So here comes step 3, and in step 3 we need to draw initial tableau. So here we go, initial tableau. So in initial tableau what we need to do is we have to draw a table and write down the elements as well as the variable. For that I will need a ruler, so let me take a ruler and draw lines. So after drawing the table, what we need to do is we have to insert the values which we have after introducing the slack variables. So here first one is y1, so right here y1, y2, x1, x2 and w, and the coefficients are 2, 1, 1, 0, 0, and then 1, minus 1, 0, 1, 0, and 3, 1. And what we need to write the coefficient of this objective function below the line here. So here we will have minus 14, minus 4, 0, 0 and 1, and we have to write here basic variables, and basic variables is x1 and x2 here. So we will write here x1 and x2. Now after writing this, what we need to do is, see here, after this we have to look for the pivotal column and pivotal element. So here you can see that the element lying below this line, most negative among these three is minus 14. The highest number carrying the negative sign is that much negative. So here minus 14 is much more negative. We are going to write here minus 14 is much negative number. So, and now what are column and rows? So vertically we move downward, that are our columns, and horizontally that are our rows. So we have 1, 2, 3, 4, 5, 6 columns and 1, 2, 3 rows. Here we need to put 0, and we have negative number, minus 14 is negative number. So our first row, this is first column. So first column is pivotal column. So first column is pivotal column. Now what we need to do is we have to divide these elements by these elements. So on dividing 3 by 2 we get 1.5. Therefore 3 by 2 divide 1.5 by 2 we get 1 by 1.5, and 1 divide by 1 we get 1. So here 1 is less than 1.5. So we have got the pivotal element, that 1 is our pivotal element, because 1 is less than 1.5. How we got 1? We divided this element by this, and least value is 1. So 1 is, so this element 1 is pivotal element. So 1 is pivotal element. So once we have got the pivotal element, our next step is to make the pivotal element unity. As you can see here, the pivotal element is already unity. So our next step is to convert the elements other than pivotal element to 0. So we have to make operation on R1 and R3 to convert the element 2 and minus 14 to 0. So we can make any element 0 only if we add some value to that number, or if we subtract some value to that number. In that case only we can make that 0, and we can make 1 either by multiplying or dividing. Mostly dividing we can make 1. So here we have to make this element 0. So I am going to write an operation for the row 1 as in step 4. So in step 4, R1 implies R1. How we can make this 2 0? If we subtract 2 from here, if we multiply this row by 2 and then subtract, then it will get 0. So R1 implies R1 minus 2 R2, means we are multiplying the element of row 2 by 2, and then we are subtracting from R1. We will get some values, and we will do that for each and every element. Similarly, how we can make the element this minus 14 to 0? We have R3 implies R3, if we add 14 to it, so R3 implies 14 R2. Now we will draw a table like we have drawn previously, and then we will do the operation in each and every element. Now guys, draw the elements. We had y1, y2, x1, x2 and w. So we will write here y1, y2, x1, x2 and w. And now see here we have pivotal element 1 which is corresponding to y1. So this time we will write here in place of x2, we will have y1. This is what we have done previously also while calculating the value of maximization. So we will have here y1. Here we have x1, so we need to write it as it is x1, and we need to do operation on R1 and R3, so I'm going to write the elements of R2 as it is. So we have 1, -1, 0, 1, 0 and 1. Now we have to do the operation on R1. So R1 means R1 is 2 minus 2 times R2 is 1, so this elements gets 0. Similarly, we have 1 minus 2 times 1 minus 2 times minus 1, so it will get plus, so we will have here 3. Now we have 1 minus 2 times 0, we will get 1. I hope you are understanding. Similarly, we have 0, so 0 minus 2 times 1 will get -2. Similarly, we have 0 minus 0, 0 minus 2 times 0 will get 0. Similarly, we have 1 minus 2 times, see here we have R1 is 3, so 3 minus 2 times 1, so 3 minus 2 times 1 we will get 1. Now time to do operation on R3. So R3 implies R3 plus 14 R2, so R3 is minus 14 plus 14 times 1 will get 0. Similarly, we have again R3 is minus 4 plus 14 times R2 is minus 1, so minus 14 plus 4 minus 18, so we will have here minus 18. I hope you could do these operations. So further on solving, we will get 0, 14, 1 and again 14 here. If not, you can leave a comment and I will explain if you fail to calculate the value. Simply put, in place of R3 we will put the element of R3, that is 0 and plus and 14 and R2 is 0 again, so we will get this 0, we have got this element 0. Similarly, we have R3 means for R3 we have 0 plus 14 times R2 is 1 here, so 1 we will get 14, so we have written here 14. Similarly, you can do this. Now we need to look for again the most negative element here. We have completed the operation of in R1 and R3. We have to look for most negative number, so this is our minus 18 is most negative number, so this is our pivotal column. And for pivotal element, what we need to do is we have to divide these numbers by these numbers, so we will have here so 1 by 3 equals to 0.3 and 1 by minus 1 equals to -1. So always remember, for considering the pivotal element we have to go for the positive value, so here it is minus, it is of no use. We will go for the least value, ignoring the positive or negative sign. So here we have 0.33, we will get 0.33 which is less than 1, so our 3 is pivotal element. Now we have to move to step 5, and in step 5 we will try to make this pivotal element to unity. If we divide the 3 by 3, then it will get unity. So our step 5 is going to be operation on R1, and R1 implies R1 divided by 3. Right here, step 5, and R1 implies R1 divided by 3. Now draw a table and do the operation on the elements of the inside the table. So here we are doing operation on R1, and we have elements y1, y2, x1, x2 and w, and we have to do operation on R1. So we will write the element of R2 and R3 as it is. So it is 1, -1, 0, 1, 0, 1, 0, -18, 0, 14, 1, 14, and we had x1 here, we had y1 here, and pivotal element was in first row, that was 3, and that is corresponding to y2. So this time after doing the operation on r1, we will write here y2, sorry for my mistake. So we have y2 and y1 and elements. So 0 is divided by 3, we get 0. 3 is divided by 3, we get 1. 1 is divided by 3, we get 1 by 3. Minus 2 is divided by 3, we get minus 2 by 3. Again 0 and 1 by 3. And this was step 5. Now in step 6, what we need to do is we have to make the elements other than pivotal element to 0. So this is pivotal element. Now we have to convert this 1 to 0 and minus 18 to 0. So now you are smart enough to know tell how we can make this minus 1 to 0. So if I write it as r2 implies r2 plus r1 and r3 implies r3 plus 18 r1. So what I did here, now what we need to do is we have to add the elements of r1 and r2 for row 2, and for row 3 we will multiply and then add. So here we go. We have y1, y2, x1, x2, w, y2, y1, and the element, we are not doing operation on r1, so we will write the element of r1 as it is. So 1 by 3, minus 2 by 3, 0, 1 by 3. Now r2 implies r2 plus r1, so we have to add the element here. So 1 plus 0 is 1, minus 1 plus 1 is 0, 0 plus 1 by 3 is 1 by 3, minus 2 by 3 plus 1 is 1 by 3, 0 plus 0 is 0, and 1 plus 1 by 3 is 4 upon 3. Now in order to do the operation on r3, so we will do here how we can do this. R3 is 0 plus 18 times r1 is 0, so 0, it will get 0. Similarly we have r3 means minus 18 plus 18 times 1 is 0, so we will get 0 here. Similarly we have r3 is again 0 plus 18 times 1 by 3, so we will get it 1 by 6, 18 times 1 by 3 we will get 6, so here we will have 6. Similarly we will get 2, 1 and 20. Now what we need to do is we have, see here we have max w equals to 20 at y1 equals to 4 by 3 and y2 equals to 1 by 3. Now in the question we had x1 and x2, so here we will write here minimum, and in the question we had z objective function z equals to 3x1, z equals to 20 at x1 equals to 6, we have to use this value vertically in minimization form. So x1 equals to 6 and x2 equals to 2. We can also apply check also. Z equals to 3 times x1 plus x2, so we will have 18 plus 2 equals to 20. So this is how we solve the linear programming problem when we are asked to minimize the given equation objective function. So I hope this video add value to you. If yes, then do share this video with your friends, and see you in the next video. Till then, stay safe and take care of yourself.